Hello, all. Welcome to another episode of AWS Show and Tell. I'm your host, Anil Nadiminti, joining from Princeton, New Jersey today. Today, we are joined by Isaac and David. We have a very interesting episode to talk about building full stack applications. But before we get into that, a quick intro, right? So, I am a senior solutions architect here at AWS, working with enterprise customers. And I'm also part of the technical field communities where we lead agentic AI conversations with customers. So that's an introduction about me. Isaac, how about you? Where are you joining from? And give some intro here.
Thanks, Anil. So my name is Isaac Privatera. I'm a principal scientist in the Generative AI Innovation Center team at Amazon Web Services. So I'm joining from Washington, D.C. Yeah, very excited for what we have to show you today.
Excellent. David.
I'm David, David Calico. I'm a senior applied scientist also in the Generative AI Innovation Center at AWS, and I'm super excited to start building on this live stream.
Excellent. Yeah. So David is going to build some applications live today. So hope the demo gods are going to be with us. But Isaac, you mentioned you're part of the GenAI Innovation Center. So we want to give some intro about what is GenAI Innovation Center and what it does. But before we head there, just let's give like a 30-second intro about what we are going to be talking about today, so the audience know what they're going to be seeing in the demos, right? So why don't we start with that?
Sure, I'll go. So it's a tool that Isaac and I led a team to build called the Fullstack AgentCore Solution Template, which is fast, and that acronym is dual purpose. It is a template to build full stack solutions on AgentCore, as the name implies. And it is useful for any agentic full stack use case. It'll help you build production quality applications fast, and it is built with the aim of using AI coding assistance to help you build.
Excellent. So we've been demonstrating how to build our applications on this live stream using AgentCore. I'll paste a link in the chat to the deep dive video series. And all along, we have shown how to build that backend of the agentic application logic, right? So, and the customers have been asking, this is great to have the backend logic, but we really want to get started fast to build the end-to-end applications, with front ends included. And this is why we have Isaac and David here. They have an open source solution that will be demonstrated today. So with that said, David, let's get started. And maybe Isaac, you can tell us a little bit about the GenAI Innovation Center and what you folks do there.
Yeah, absolutely. So the Generative AI Innovation Center team is a team of scientists, engineers, and AI strategists that focus on building generative and now increasingly agentic AI proof of concepts with the goal of going to production. So we want to take customers' ideas and help them move from ideation all the way to production. And we've done that with a number of different customers. And we've done it basically since generative AI applications started coming into play. We basically, since ChatGPT came out, we were formed, and we've been building proof of concepts with a number of different customers, PGA Tour, NFL, Thomson Reuters, some great customers. And so we've got some excellent stories. We've learned a lot of lessons in building all of these different proof of concepts. And one of the things we really wanted to do is distill those lessons down. And that's part of how FAST is born.
Excellent, right? So that's great. So tell us more about how you operate, right, within the GenAI Innovation Center. Do you take in requests from the customers? From how do people reach the GenAI Innovation Center?
So the way it typically works is your account team. So you can either ask to contact us. So we have a form, and I can show what that looks like.
Sure. Let me
and so you either can reach out through your account team and you can put in a nomination, or you can go to our website. So we have this nice site that shows you exactly what we do, some of the different proof of concepts we've done, some of the areas we focus on. And in particular, if you would like to try to get started with us, you can click on this button. So start building, and then that will send you to a form where you can contact us and then can submit a nomination for us to help you build a proof of concept.
That's excellent, right? So there is a mechanism to reach the team. I am sharing the link in the chat here for folks who are coming in. Uh, and with that, Isaac, so anything else you would share about the Innovation Center?
I think just that, we've grown quite a bit. And I think that now, we've been doing a ton of work with building agentic proof of concepts. I have a couple slides that I can go over to talk about, some of the things that we're doing and some of the ways that we build. We're really excited about AgentCore. We've been big proponents of that. And I think that, one of the things that we've seen in our time is that it's really easy to just go to GitHub, go grab a sample, and then get some cool answers from it. But taking that agentic AI, kind of toy example and making it production grade is a whole nother story. And I think that, we've learned a ton of lessons in all the different proof of concepts we've done. And so we take those lessons and we apply them to everything that we build.
Excellent. Yeah, if you can get started, let's get your screen share up and we'll take it from there. But folks, we are going to be doing some demonstrations here of some code samples. David is going to bring these live, build these live. So let's get there. And here we are. Isaac, I think we lost your audio there.
You're muted, yeah.
Sorry about that. All right, let's try this one more time. There we go. All right. So already did introductions. And I was talking a little about this before, but moving agents from prototype to production is difficult. So when you are building any one of these proof of concepts, as I mentioned before, grabbing a GitHub sample, easy to get started, but taking into account all of the different factors that you need in order to make sure that your agent really is performing at production scale, understanding your performance. Can your agent scale to all the requests you're going to get? Is it secure? Are you passing tokens in? How are you governing it? So this is where you're able to get real value out of these different agents that you're building. And so we, as the Innovation Center, were super excited when we came out with Amazon Bedrock AgentCore. And so AgentCore provides you the tooling in order to build these different agentic production grade applications. And so we have primitives that range from agentic hosting, which would be runtime, which I like to call kind of Lambda for agents, memory, identity, gateway, which is for having your MCP servers or taking tools and making them MCP compatible and exposing them to your agent. Some very cool first-party tools that we offer, including code interpreter, browser, and then some of the things that I think are not as flashy, but are extremely important for taking an agent to production, which would be observability, policy, and evaluations. So we're very excited about this, but one of the things that we saw in AgentCore is that there's all these different individual primitives, but there isn't necessarily a flexible single kind of template or starter kit that you can use to stitch all of them together for a single application. And that's how FAST was effectively born. So what we wanted to do is we wanted to build in a starter kit that would allow you basically to take all of the best practices that we've kind of distilled down and have a really great place to start building applications from. And so I think that one of the things that we wanted to do is we wanted to make sure that it was simple. So it's very easy to take it, deploy an agent, and then get all of the different components that you need. So you get the front end, you get authentication, and you get really a full stack agentic app. It's maintained by us, the Generative AI Innovation Center. So as new primitives come out and as we learn new best practices, we are going to take that back and integrate it back into FAST. And it's designed for vibe coding. So we wanted to make it, the core infrastructure is based on those best practices, but it's super vibe friendly, as David's going to show, and it's designed for AI coding assistance in mind. So it's complete with steering docs, feature guides, and readmes. And with that, I think ready to hand it over to David to build some cool stuff.
I like how you said that it's vibe friendly. So because nowadays everything is, yeah, I think maybe that's the new norm to make application coding vibe friendly. So there we are. All right, David. So let's bring this up.
Oh, fantastic. Yeah, it's vibe friendly, but it is also important that this isn't going to just build an application for you. Like, this is helping you build an application. So it's this nice middle ground where if you don't want to use coding assistance, you can open up Emacs or Vim and clone this and still build just fine. But it is enabling vibe coding built in. So yeah, so let's get started. So this is the GitHub repository, which I hope we can share the link.
Yep.
The call to action immediately is to star it, clone it. You can work alongside me in this stream or watch this later, but this is all open source, and it's where I'm starting from. And as Isaac mentioned, it has steering docs and all these things. It has infrastructure as code. It has tests, tools, things like that. And the README is nice and descriptive. And down here, I want to get to the architecture diagram. And in fact, I have this in a different tab. So this is when you clone and deploy fast out of the box, this is what gets deployed into your account. The front end is hosted with Amplify, which you can swap out. Cognito is used for authentication. This whole block is the AgentCore primitives stitched together that Isaac was talking about, including runtime, sort of like the Lambda for agents. There's a code interpreter for more secure code execution by your agents. AgentCore memory, AgentCore gateway, which the tools live behind, and observability. So this is all what just comes out of the box. And up here, a full stack application is not only going to be talking to an agent, you're also going to need REST APIs and things for application data. So what we did was we built in just a sample Lambda, which talks to DynamoDB behind an API gateway. In terms of tools, we have one or two really simple basic tools. And you're able to choose between using strands or LangGraph, or more to come. You can use whatever agent SDK you want. So this is the architecture diagram. And when you clone it, it will tell you, here's a URL for you to go access, and here's your application. And this is what the application looks like. And as you can see, it is super simple, bare bones. And that is on purpose. This is not a toolkit where you can clone it and you have an application that you can share with your users. It is meant to be customized, and it's meant to be the starting point from which you customize and create your own application. So it comes with two built-in tools. Let's see. Let's just chat with it and see what happens. I think it is using one of the Claude models in the back end, but you can use whatever you want. It says, okay, I've got a text analysis tool, which analyzes a block of text, and I have a Python code executor. And these, again, are meant to be torn out and replaced. And in the build, which I'm about to do, I will tear them out and replace them. But just to show you, like, the text analysis tool, let's see, analyze this. You can see this, right? This text. Sure, there's a block of text. And I'm not, the LLM here is not analyzing this text. It is taking this text, identifying, oh, I have a tool that is used for analyzing text. It is sending that text through the AgentCore gateway to, so here you go. So the agent is sending that text through the AgentCore gateway to a tool, which is deterministically analyzing the text, giving it back to the agent, which is responding to the front end. And this, again, is a dummy function where it's just counting number of characters or whatever. But this actually is something that an LLM itself can't really do very well. So it makes sense to have a tool here.
So while we're talking about this, David, maybe if I can bring you back to your architecture diagram there. For folks who are not familiar with AgentCore Gateway, let's talk about that for a second, right? So I see that you have a Lambda function there, but what is the AgentCore Gateway doing here? Or what could it be doing in general?
Yeah, so the gateway is a gateway between your agent and tools. And you can have lots of different ways to attach a tool to a gateway, through a Lambda function, through your own MCP servers, yada, yada, yada. And what the agent is doing when you send it the text, analyze this text, it says, what tools do I have available? It goes to Gateway, and Gateway tells it, these are the tools that you have available. And the agent says, I would like to use this one with these arguments, and it goes through. It also is providing all sorts of authentication capabilities. So certain agents can only access certain tools, those kinds of things. That's what Gateway is there for.
So you're essentially MCP-fying the APIs to be available for the AI agents. And let's say in this case, your agent is going to be talking to something like a Google Drive to access the content. It should be secure, and you need to be able to pass those tokens to the backend, right? So that's all that the gateway is doing here. So this is great. All right, so let's keep going.
Yeah, so let's keep going. So there's also a code analysis tool, but in the interest of time, I'm gonna move on, and I want to start actually building something, right? So what do we want to build? So just to pick anything to build on this stream, I chose this Strands Agents samples, also open source, and it is just an IPython notebook. And in this IPython notebook, it allows you to talk to some Strands agent, which has access to some tools which are connected directly to it to create appointments or list appointments. It's kind of like a personal assistant type app. And it saves those appointments in an SQLite database. None of this is in AgentCore. This isn't scalable. There's no user auth. There's no front end. It's just an IPython notebook. But I love this notebook, and I want to turn it into a full stack application. So that's going to be my goal. I'm going to try my best to do it during this stream, but you know, the curse of doing live demos, I'm building the demo live before I do the live demo. So we'll see. But if I don't get to complete it, I have already built this like in a practice round, so I'll share it with you.
Excellent.
But regardless, so this is the architecture diagram of Fast. And I am envisioning for this personal assistant app, I want a front end which maybe displays a calendar and it shows my past appointments. And maybe there's a chat window where I can say, make me a new appointment or delete my appointments or something like that. And I probably want to store those appointments in DynamoDB. That's nice. There's already DynamoDB deployed, so I don't need to figure out some new database backend. And the agents are going to need to be able to, through Gateway or some other way, create appointments. But in my front end, I'm just going to display a calendar. So that should be able to retrieve my existing appointments and display them without anything agentic. There's no Gen AI there. So I'm envisioning in my mind, and we'll see if this is what we end up actually building, an architecture like this. So the main differences are, this is an appointment related Lambda. So I'm changing that Lambda. This Lambda, instead of the silly text analysis, I have some appointment tools, create appointment, delete appointment, things like that, that read from the same table. I got rid of the code interpreter thing because this use case doesn't involve executing code. And I've decided to go with Strands. So this is what I'm hoping that we end up getting to, just to get you all envisioning the same thing that I'm envisioning. So let's get started. I'm going to be doing this with Kiro, which is a coding assistant from Amazon. You can use any coding assistant. You can use no coding assistant. Fast will work with all of them. And before this live stream started, I did just deploy the out-of-the-box thing as I was showing you. In fact, this exact application is what we are going to be editing and changing and turning into a personal assistant. So I deployed that just to save some time. And so I just want to show you what I did to do that. This is VS Code. Hopefully this is big enough. I opened Kiro CLI and I said, I'm new here. My goal is to deploy the application. I just created a conda environment. What do I need to do? And it, from the steering docs, it knows exactly what files to read. And it says, here's what you need to do. These are the prereqs you have to have. You got to install these things. And it will do these for you, actually, if you ask. And then there's CDK deploy. And then there's a separate script to deploy the front end. It says, before you deploy, you can change the configuration to give it a custom stack name. So you can deploy multiple things. Great. So what I said was, edit my config to call the stack livestream fast. My email is Calico. Help me deploy it. And I said, if possible, pipe the CDK deploy output somewhere so I don't have to read them because it's kind of verbose. Mm-hmm. So Kiro does this, and it deploys the CDK. And again, I'm scrolling fast here, but you can sort of like, my narration is kind of all you need at this point. And it checked the outputs to make sure it worked. And indeed, it did work. It deployed the front end and it said, here's your URL. And that's what I was clicking on earlier. So what we've done is we've deployed fast out of the box with just a few natural language like, hey, Kiro, can you deploy this for me? And I've showed you that it worked. And we have an idea for what we want to do to customize it into the personalization assistant.
So this is the first step, right? So clone the repo, get this, or maybe we should say start the repo first, then clone it.
Yeah, start first, then clone it, then deploy it, and you'll be at exactly where I am right now. And so also, since I have an IPython notebook that I wanted to work from, I also just downloaded that, and that lives here. This is exactly what I showed you. So it's in this directory. So how do I want to start? I'm going to close this just to make this bigger. Let's see. Great. I always am polite to AI, which I don't know what that says about me. I want to now customize Fast into a personal assistant. Here is a IPython notebook with strands agent code, and I'm just going to tell it, go read this. And in fact, I'm just going to say, go read this, understand what it does, understand what Fast does, and let me know when you're ready to start building. And this is just an approach where I want to make sure that it has all of the information in its context window sort of before we begin. If I were doing some long-term building on this application, I would probably just add that IPython notebook to like the Kiro context, so it's always there. Great. So it read the notebook, and it says, this seems to be a strands notebook with custom tools. Fast's current agent here's a description of it. In order to build it, I'll need to do these things. SQLite won't work. We'll need to use DynamoDB. Great. I mentioned that earlier, so it figured that out on its own. It's going to need the current time, so I can make an appointment like make me an appointment in 1 week. You need to know what today is to figure out what 1 week from now is. It's so on and so forth. The key decision is that it uses SQLite, which is ephemeral. So for Fast, we should use DynamoDB. So let's see. For the sake of doing this on a live stream rather than typing it out, this is what I want to say next to the agent. So read the Fast docs and come up with a plan to adapt this notebook to better align with the production architecture. I think Fast already has DynamoDB somewhere, right? Can we use that? And it's already figured out that that's what it wants to do. And I say, come up with a detailed implementation file, a plan, and save it to a markdown file so I can review it before you begin implementing anything.
Maybe
also, I want to go ahead.
Are these prompts also in there, or are you, in the sample repo?
No, this is just me. I just put it in a file so that on a live stream you wouldn't have to watch me slowly type.
Correct. Okay, perfect. And then
but
what model are?
Say what?
What model are you using as well, right? So
for Kiro right now I'm using Opus 4.5, but Claude Opus 4.5. But I've done this with far weaker models. It's pretty good. With the level of documentation in Fast allows much weaker models to be pretty effective here.
One thing I'll add, though, is that as David's doing here, it's always best practice to just be specific about what you want when you're doing any kind of vibe coding. Just because if you're not, it's going to start making decisions on your behalf. And then you might wind up with something that maybe you don't want as much as something where if you give an opinionated view, it'll build you what you want.
That's great. And we are also looking at Kiro CLI here. There is also an IDE version that you may want to check out. I put the link in the chat. So the IDE version also has autonomous agent building capabilities. And there is a lot to unpack there. We have other streams that talk about Kiro build using the IDE as well.
Great. Yeah. So just to jump in. So what it's doing here is it read all of these different things that it needs to read, and it has a complete picture, and it's going to create an implementation plan. And this is important for two reasons. One, as a human, before it begins, I want to read it and understand what it's doing and ask questions to make sure it is going to do what I want. And also by having it save in a file and sort of update that file as it goes, if I get disconnected or my computer dies or whatever, and I can start up and just pick up right where I left off by saying, read your implementation plan and pick up where you left off. If you're using the Kiro IDE, it kind of does this for you. This is like the spec-driven development. I'm just using VS Code and the Kiro CLI, so I'm kind of doing that same thing myself. So let's see. It made implementation plan, right? So let's look at it. I think it's this one. Yep. And let's look at a preview, and I'm going to try to rearrange some windows because you can see. Okay, so this is the plan that it just created this document. The current state, okay, target state, okay. Architecture decision, Gateway, Lambda, and DynamoDB. That's great. That aligns with what sort of FAST was built to do. So it is reading the FAST steering docs and understanding that. For the implementation steps, it's going to create some new table in DynamoDB. That sounds good. It's going to create an appointments Lambda to add to manipulate that DynamoDB table. It's going to create a tool specification. It's going to update the backend stack, replacing the sample tool with the appointments because I wanted to get rid of the sample tool. It'll update the agent. It'll update the requirements. And these are all the files that it needs to change. It tells me the DynamoDB schema it likes, the tool specs that it's going to use. And if I weren't on a live stream right now, I'd be reading this a lot more closely, but I'm trying to get it done. And then it'll deploy it, and then it'll test it. And it says, please review this plan. So let me poke it a little bit and say, the plan looks good. How will you attach the tools to the agent? And let's see what it says. Is it going to use, because there's different ways to do it, right? You can use AgentCore Gateway. You can attach them directly. So the agent already connects to Gateway tools. So the agent changes are minimal. Okay, great. So to be clear, you will add the tools behind AgentCore Gateway, right? Let's just make sure. Great. So it's going to do that. And in fact, I built this app 2 or 3 times, and it makes different decisions sometimes. So you can sometimes you can say, stop. Is this really best practice? And it will read the FAST documentation and see, oh no, it's best practice to put for these situations, put it behind the gateway. So let's do that. Okay, so it's got a good plan. Before we start building, let's do this. Additionally, I think I'd like to eventually include something in the front end which displays appointments in a calendar view. This is what I was describing earlier. That way, when I add or delete them through the agent, I can see them appear or disappear. I haven't figured out exactly how to do that, but I want to make sure that's possible. How do you recommend that I do that? So I want to make sure that it sees the full app that I'm trying to build. Option 1, API Gateway Endpoint, recommended. Option 2, reuse the Gateway Lambda. So it says it recommends adding a dedicated appointments REST API endpoint. Will that reuse the existing API gateway or create a new API gateway? Just to clarify, I want to understand what it does. Okay, I'll update the plan to reuse the existing API. Great. Great. Yes, update the implementation plan.
Great. So we are asking Kira to update the plan so that we could kick it off and let it cook for a little bit before we go into some of the details of FAST here.
Yeah, exactly. One more question that I want to clarify is there's a user ID that needs to happen here. I don't want me to log in, Isaac to log in, I make an appointment and it shows up on Isaac's calendar. It needs to be somehow sharded by user. So I want to make sure that it is doing that. Sorry, it's still updating the implementation plan.
Another thing I want to call out is that the original API gateway and the DynamoDB setup, that's actually set up so that agent, when you're using FAST, there's a thumbs up and thumbs down icon in it. So anytime you do that, that's actually getting logged to DynamoDB. And so we are logging that feedback because one of the things I think that gets overlooked when you build agents is people will build really like elaborate offline evaluation setups. And there's a number of different tools to do that. But having a way to capture that online evaluation and get that thumbs up, thumbs down data and store that, that's really valuable information. From like kind of a science perspective, when you're doing this offline eval, effectively what you're trying to do is you're trying to capture a distribution of questions and kind of things that your users are going to do. The actual traces in the usage, that is effectively the distribution you're going after. So capturing all that data, using AgentCore observability, using AgentCore evals, which now operates on top of traces, can give you a lot of insight into that. So I think it's a really important thing that we built into Fast to be able to capture that feedback. And also observability is built into it as well.
Excellent.
Gotcha. So just to get you up to speed, I asked it, how do I make sure that it's sharded by user, basically? And it said, ooh, that's important to consider. And it says, well, there's different options. And I chose one that I thought was okay. I will say that in the future, this is a lot of what AgentCore Identity is for. And it is not integrated to Fast yet, but it is like on our immediate roadmap. So for now, I'm having the agent pass the user ID directly to the Lambda function. But anyway, it's done that. It's updated the implementation plan, and now we can let it start to build. And you can, when you're using Kiro, hit the T character, which trusts it to use tools, and it will do all of this automatically, like without you having to hit Y. I personally prefer not to do that because I like to read what it's doing. So I can explain a little bit as it goes. So it's going to create a tool spec for appointment tools. There's a create appointment, list appointments. Great. These are tool specs that the AgentCore gateway will use to define these tools and tell the agent in a very specific way what tools exist for each tool, what the required input arguments are, what you should expect as a result from the tool, those sorts of things. So it's starting by making that.
Yeah, while that's happening, we have a couple of questions in the chat. Like, let me bring this up while that's going on. So how do we ensure enterprise reusability, right? So this is a question that's in the chat, and we're going to touch on that as well as.
Yeah.
Mm-hmm. Go ahead.
Yeah. So, and that's like a kind of a broad question. Like maybe I'll let Isaac chime in too. But in general, putting tools behind a gateway is a big step towards reusability, because you can have all of your tools behind a gateway and lots of different agents talking just to that gateway. So you don't need to attach every tool to every agent all the way. By putting it through literally that gateway, you're able to reuse a lot of your tooling and a lot of your agents.
And the next question also is, from Dhyaneshwaran. For observability, if I'd like to integrate third-party tools like LangViews, can I provide specifics in Fast template, or would it be done outside of Fast?
Yeah. So for observability, or maybe like Isaac, do you want to take this?
Yeah, I can take that one. Okay. So the way that you do that is with AgentCore observability, everything is logged using OTel, which is open telemetry, which is a pretty broadly used standard. So you can, it's not directly done in Fast, but you can port those, like stream those logs directly to LangViews. And so you would be able to take all the logs that are in AgentCore observability and get them into LangViews via observability.
Right. And we also have a comment from Stuart. The agent is making tools for itself, right? So this is the new trend now. We've been seeing a lot of that.
Yeah. It's making tools for itself with explicit guidance and oversight from me, which is also important.
For now, right?
Yeah. For now, yeah. But okay, so while we've been talking, it's making the Lambda functions which access DynamoDB. It did the tool spec. Now it's updating the actual CDK code, which is deploying the whole application with these Lambda functions.
Oh, and one thing I wanted to mention, because we were talking a little bit about enterprise reusability, we expect that you're not going to just use this out of the box. So, and we designed Fast to be modular. So for example, like, let's say you wanted to take out some component. You have like your own like hosting solution. Like that's pretty, we made it so that it's straightforward to be able to make those modifications too fast. We completely understand there's going to be enterprise hardening that needs to happen. But what we wanted to do is give you all of the kind of main pieces you needed to build on top of, and then you can take Fast in whatever direction you want.
Makes sense. So get started, right? So we have all the framework here, and again there is a shared responsibility model, so that you evaluate what you're building, make sure that it's secure, and then deploy it to your customers.
Got it. So what it's doing now is that it's modifying the actual agent. It's changing the built-in system prompt to the one that it got from that IPython notebook, which is related to being a personal assistant. And now it's getting rid of the code interpreter because we don't need that. We could have left it in there. It's serverless. It spins up only when you need it, but best practice to clean it up.
We also have a question from Mike asking, for enterprise applications, what would be the best approach to manage code repo out of Kiro for additional new features and bug fixes? So I'm assuming Mike is referring to the fast template and how you could manage that. Isaac.
Yeah, so we're going to be continually updating fast for any like new additions, and we have a roadmap that we're working on now, where we're going to be adding, as David mentioned, identity, AgentCore policy. Once that's GA, we're going to look into integrating that as well. So we are going to be keeping it up to date. I think the expectation is that you probably fork fast. But what we want to do is make sure that, and one of the things that I think also that we wanted to make sure with fast is that it stays simple. So the core repository, we're not going to ever add too many bells and whistles to it. We're working on a samples repository where we're going to have much more in-depth samples that exist. But the core of fast, we wanted to keep simple, and that's on purpose. So we'll be releasing new things to that core package of fast. But one of the things we wanted to do is make sure that it stays simple and it stays easy to maintain.
Okay, great. So so this is close to being ready to deploy the backend. In the interest of time, normally what I would do is I would deploy the backend, check to make sure it works, and then start modifying the front end. In the interest of time, I'm going to modify the front end right now before it deploys. And then I'll deploy it all at once. It'll take about 5 minutes to deploy. So while it is deploying, Isaac will showcase one or two applications that were built on fast. So you can sort of see the diversity of applications that you can build using fast. All right, so let me show you how I would modify the front end. This is also a copy and paste. So great, the backend seems to work. I see the DynamoDB table created. I added an entry into it. This is hypothetical. Now let's work on the front end. And the front end is React. I do not know React, but I know that Claude or AI agents knows React really well. So you should not be afraid of, you shouldn't clone this and say, oh no, the front end's React, I'm never going to be able to change it. The front end is the easiest part when you're using AI coding assistants. So I'm just going to say, remove all the generic full stack template text, create a generic personal assistant page with fake content and some lorem ipsum text, make the chat window pop up from the bottom right, and have a calendar front and center in the page. The calendar will get the meetings from DynamoDB through the REST API.
So at this point, you're customizing the template, right? The original template, and making
correct.
it.
Yes. So I'm taking this front end, which is in the repository, and I'm telling the AI agent, just make it look like a personal assistant, and here's a few minor changes. And once you get that up and running, actually, tweaking the front end iteratively is kind of the fun part of building these applications, because you can really make it snappy and do exactly what you as a user wanted to do by just describing it with natural language. So that's kind of the fun part. I'm sad that I'm only going to make one change here on this live stream, but so what it's doing is it's creating an appointments service, and this is all in the front end directory. Let's see, what is it doing next? It is creating the calendar component. Hit Y. It's going to make a floating chat widget. So instead of being front and center, like how can I help you, it'll be off to the side.
And while David is doing all of this here in CLI, again, Kiro IDE has spec-driven mode where all of this can be done ahead of time as well. This is one way to build the application.
Yes.
There are multiple ways to use the same template where you can define everything upfront and then let Kiro, maybe press the all button,
Yeah,
I guess, right?
that's
So
a disclaimer that I wrote down that I wanted to give at the beginning of this, which I forgot, which is I'm just doing this in one way with one set of tooling. There are infinite ways for you to do this. And also the way that I'm doing it, I'm not claiming that's the correct or optimal way. This is for you to try out. Okay, so it's building the front end. What I'm going to do before I deploy the front end is I'm going to deploy the back end. So do you mind if I hand it off to Isaac? I'll deploy this in the background while you show some samples.
excellent. Yeah, and I also see that David has called this out about using Kiro powers to be able to build the templates and build your application using that, right? So great call out there, David. Daniel, I think, yeah. So, all right. So while we're doing that, Isaac, how about we float back to your screen?
Sounds good.
Right.
All right, so I'm just going to show a couple different applications that some of our awesome scientists have built. So this one was built by scientist named Austin on our team, who is great. So this is a data analytics agent. So what this is showcasing is text to SQL, as well as a number of different really cool visualization capabilities that Austin built into this sample. So let's start out with a pretty straightforward question. Tell me what tools you have access to. And by the way, out of the box, everything with Fast is built to support streaming. And so we also have set it up so that you can do multi-agent streaming, which I'll show in a different sample later. So this is a pretty simple question. So let's now ask one other kind of clarifying question. And so what data this has access to is like a music database. It'll tell you in a second, but effectively what it's looking at is it's got a number of different like artists. So it's all about like music. And then I can ask a follow-up question, tell me what the top 5 artists by sales are. And what it'll do is it's using some different tools. And you can see one of the really cool things I think about agents now is a lot of these agents are set up so that they can do parallel tool calling, which I think is a really, really powerful capability. And so here you can see, in that kind of very short period of time, all these different tools are being invoked, describing the tables, calling a SQL query, analyzing the data frame. And one of the things that I think is really cool to highlight is the power. I know David stripped it out of our example, but the power of the code interpreter. I think the code interpreter is one of the coolest things that we built. And the reason for that is when you're thinking about like an agent and its ability to handle different kind of really heavy analytical tasks, in a lot of cases, it's much better to have the agent write code to do it, execute that code in a secure environment like the code interpreter, and then get the results back versus trying to pass everything into context and have it do it on its own. It's going to save you money as well if you do that. So we'll do one more question here, and then I'll pass it back to David. So this is a pretty involved question here. So this is calculate the correlation coefficient between track length and sales, determine if it's statistically significant, and make me a scatter plot of the relationship. So you can see we're using the code interpreter. We're doing interactive plotting. And we're getting an actual plot back, as well as like some very detailed descriptions of what's happening. So I think this is one of the coolest things about, as I mentioned, this code interpreter tool is the ability to execute code. You can do things like generate visualizations, embed that into your UI, and do that all in parallel with multiple different threads going on. So just wanted to show some of the cool things that we've had people build with Fast, and we're really excited for other folks to build their own interesting applications.
Nice.
Yeah, so this is still deploying. So we can either, Isaac, do you want to show another example, or I can sort of just show what it's working towards?
Sure, I can show one more example. So this example is a little bit more meta. And one of the things that I'll say about it is so one of the things I think is really important, I've talked about this a couple times, is taking agents to production. When you have all these different agents in your organization and they're propagating, it's really important to be able to understand what your agents are doing and to capture that. And so a different sample that I and some of my team built was this multi-agent monitoring system. And so this is one where when you have multiple agents, you want to understand what are they doing, how are they performing, and how can I analyze their performance. So this one is pretty, I'll refresh this here. So this is a pretty bare bones UI. I'm going to add a little bit more to it. But basically the idea is that this is a monitoring system that allows you to get an understanding of what agents exist. And by the way, this is a multi-agent system. So you can see that similar to the tool invocations, I have my sub agents showing here. And so this one is built out of a monitoring agent as well as an analysis agent and a supervisor that's coordinating them. But you can see that we're getting sub agents streaming directly from that sub agent. And that's like a really important thing, because if you just have the supervisor streaming and you're using a multi-agent framework, that can be kind of a frustrating user experience because you're not getting to see what that sub agent is actually doing. So we can see here, we've got a couple agents that are registered. So let's go ahead and ask now. One of the things we might want to know is, what does the prompt look like for this specific agent? So now my monitoring tool is going to go pull the prompts for this agent that is in our registry, which is, so this is a registry that's just a DynamoDB table that we built on top of this fast sample. And so what it does is it just allows you to get an understanding of, what agents exist, and then, where their different components live. So I think it's really important to have an understanding of, in your agentic ecosystem, where are things deployed, what tools are they using? And so this is set up using Bedrock prompt management. So we're able to just programmatically retrieve all the prompts. So here we can see, this is a travel agent that I have deployed. It's got a cart manager, it's got a travel supervisor, and it's got a travel assistant. So these are some of the available tools. These are some of the rules. And these are the different, components that are going to be in our prompt. And then finally, I'll show you one thing that I think is really important. And this lines up back to what I was talking about, the feedback table, is we have that feedback set up in that table so that you can pull these results and then get live understanding of, what kind of feedback am I seeing when it comes to my agents in production. So, are they getting like thumbs up? What kind of comments are they getting? And so this will give you like a much better understanding of like what kind of feedback are my agents getting in production. And I can show you, because sometimes that takes a little bit of time. So I have this one ready. But basically what you can do then is you can also say, what modifications should I make to my prompt? And then it will give you kind of like actionable modifications, basically saying, this is what you should do to your cart manager. This is what you should do to your different sub agents. And this is how you implement it. And I know we're short on time, so I'll hand it back to David.
So this is
Awesome.
an example of how we built like applications, end-to-end applications using the FAST framework, right? So these are only some examples here, but yeah.
Yeah, we have a bunch of examples that are all sort of internal for now, but we have a plan to, like as Isaac was saying, we'll have the FAST repository, and then we'll have like a FAST samples repository. So you can see, how did someone switch out Cognito for Okta or something? You can see a sample where that's done. But yeah, so this is done deploying, and it gave it exactly like a nice orange theme. And so when I log into the page, I see this calendar. I made a haircut appointment while you were talking. And so, for example, let's say make an appointment for February 17th for a haircut. Or let's see. 2026 to be clear, for a haircut for me. And let's see what it says. And so what's happening now is that this is the architecture. It sends that text to AgentCore. The agent is using strands with some built-in tools. It's perhaps talking to Gateway, and it's coming up with a response. And that response is, I'd be happy to help. I need more details. So what time? Haircut is at noon at Isaac's Salon in Washington, D.C. And again, this is a super simple app. But if you just do what I did for longer, you can create anything that you want, and it will be scalable, authenticated, all the things that come with AgentCore making things more production quality. So it made this appointment and it showed up on my calendar. And as a reminder, the reason that it's showing up on the calendar is because the front end is going through this pathway, the REST API, to read from the table what the agent had gone through AgentCore Gateway to write to the table. And then there's also the, delete all of my appointments, because we added that in the next week. So in order to figure out what is the next week, it has to use the current time tool to figure out what today is. And there you go. You have one appointment, and I'll delete it for you now. So now the agent is going through here, calling the delete endpoint. It is removing it from the DynamoDB table. And also, as I mentioned, the user ID is passed all through here. So it's only able to delete my appointments. It can't delete someone else's appointments. So I guess just to recap, we started with this IPython notebook, and we had a dream for an application that we wanted to create. We identified that if we started with fast, we're like 90% of the way there, already on AgentCore, scalable, all those things, nice front end. We didn't even actually write any code. We just only use natural language through Kiro, but you could write code if you wanted to. And we ended up with this personal assistant app. And from here, you want to be able to click on this and have it open something, just tell that to Kiro or whatever, and we'll add those sort of features. And yeah, those are the points that I'm making. The last thing is that we mentioned there was the feedback API. And this is what Isaac was talking about, which was critical to collecting feedback from the users. So you can do this, and it would send it to DynamoDB. And so you could have, for example, a display of your feedback. The world is your oyster if you start with fast.
Now, David, as we get into some details here, and this is a great demo, looking at an application being built right on the fly. Can you go to the repo and show where is all of this coming from, right? So maybe what's the brain of fast here?
Yeah, so there's two things I want to show, actually. One of them is the repo. So there's docs, which represent best practices, lessons that we've learned through our engagements with customers, which is kind of something that differentiates this from others. There is gateway tools. This is where the infrastructure lives for CDK. We're coming out with Terraform support soon. The different agent patterns live here. We have line graph and strands. It's straightforward to add more, and we plan to do that. Also, this is open source. So if you want to add one for your own agent SDK, do it and submit a PR. I would be grateful. And also, I mentioned that this is suitable for lots of different coding assistants. So you see there's Amazon Q, Kiro, Klein. You could add more. These are all symlinks to this vibe context. So this is the vibe context that tells the coding assistants, this is where the various files live in fast. Make sure you follow these best practices. And it works for any coding assistant. Now, the last thing I want to show you is that even if you don't want to read this repository or understand it, there is an absolutely wonderful open source tool called DeepWiki. And if you're not familiar with DeepWiki, you should become familiar with DeepWiki. It has indexed every GitHub repository that there is. And if you have any questions about how fast works, like, for example, how does the front end connect to the back end with authentication? Any question that you would think to email me or create a Git issue, if you ask it to DeepWiki, it does a phenomenal job at understanding the code and answering all of your questions. So this isn't even just a fast tip. this is any code base on GitHub tip. I recommend using DeepWiki.
Great. And I have a question here in the chat. Right. So from Kaushik, does FAST provide any latency improvements over our current AgentCore runtime plus gateway setup with Lambda and MCP targets, or is it primarily focused on front-end integration and infrastructure framework?
I don't see it improving because it's still using the AgentCore runway and gateway. So I don't see it improving latency there. It's not optimized in any sort of way. It's probably similar to what you're doing with the front end integration and the auth integration.
So it's providing a mechanism for deploying the full stack applications. It's not necessarily optimizing on performance there.
Yeah, and I would also point out that in our experience with customers, if you are not, you'll notice that the FAST personal assistant streams the response. If you're not streaming and you have a concern about latency, the first thing, in my opinion, that you should do is start streaming, because a lot of this is psychological, the impact of the latency. And if that 11 seconds was time to last token and you start streaming and it's 3 seconds time to first token, technically you have the same latency, but your users will be super thrilled instead of super impatient. And FAST supports streaming out of the box.
One thing I'll also add, for any kind of troubleshooting of that, AgentCore observability logs everything to like CloudWatch. So I would go into your logs, go look at that waterfall chart, understand where are the highest points of latency and where can you kind of optimize.
Yeah, I didn't even show that here. So AgentCore observability is also built into FAST. I could have opened my console and gone to observability, and I would have seen the workflows that the personal assistant was doing.
Or the tokens used, or
tokens used, the costs, all that stuff. I don't have it open now, but it's that's just there automatically.
Excellent. This is great. Thanks for building the demo live on air, David, to show the capabilities here, and I'm glad it went well. Yeah. So any closing comments, right? I know we have folks who are watching to know more about FAST and understand. So what are some closing comments, right? So regarding building these full stack applications on FAST.
Start building
with FAST.
Yeah. Start building. Even if you don't know how to code, like I didn't actually write any code there. And even if you don't know how to clone the repo, if you have Kiro or something, say, here's a URL to a repo, how do I get started? And you can get started. So that's the first thing. And the second thing is, use FAST specifically because we made it and we're trying to increase the adoption of AgentCore.
Yeah, and third thing is, start the repo and then start using.
Start the repo.
Yeah. And one thing I'll also add is that, we're going to be constantly iterating on FAST. This is not the final version of it. So we're going to keep adding features, trying to maintain its simplicity, but also we're going to be working on showing how you can build some really cool stuff using FAST and how it can accelerate you.
Thanks. Yeah. So that's it from our side in this episode. Thanks for watching, folks, and we'll see you next time. Thank you all.
Thanks.
Thank you.